And now, without wasting any time, I would like to call upon Dr. Azra Munirah Binti Daud, our last presenter for today, to present her research entitled Issues and Challenges in Rainwater Harvesting for Potential Potable and Non-Potable Water Production. Please welcome.
Okay. Assalamualaikum. Thank you, Ms. Chairperson, Dr. Suzana. Assalamualaikum and very good afternoon to all distinguished guests, all presenters and also participants. First of all, can you hear me clearly? And you can see my slide?
Yes.
Yeah,
okay.
Very clear, Dr. Azra.
Yeah, very clear.
Okay, thank you. Okay, thank you. So the title of my today's presentation will be Issues and Challenges in Rainwater Harvesting for Potential Potable and Non-Potable Water Production. Slightly changes from the previous topic that I've sent to the Secretariat. So I'm Azra from an academician from UTHM. So these are the outlines for my today's presentation. I will start with motivation, the aim, and then we go to the objective, and then right into issues and challenges. I divided into quality and health risks, and second one energy consumption and design aspect, and then we go for the results and discussion and the conclusion. So, sorry. So as we all know, Malaysia is blessed with abundance of rainfall throughout the year, like what Prof. Emeritus Dr. Hamid Hashim has mentioned this morning in his keynote session. We receive about 2,400 millimeters of rainfall every year. So this shows that rainwater is our very precious resource of water in our country. So that we have, so that in this seminar, I would like to highlight again what are the issues and challenges in implementing and also in practicing the rainwater harvesting system for both potential potable and also non-potable that we still got it currently still in debate, and we need to highlight one by one so that we can come up with better conditions of implementation of rainwater harvesting system. So as we know that this method has been developed in thousand years back, ancient society, that they use this harvested rainwater for their activities like agriculture, construction in an urbanized area, and also they commonly used in semi-arid countries. Okay, so the advantage of these rainwater harvesting systems are reducing the rely of water supplies on the conventional domestic water supply, and second one, reducing some water runoff that could degrade the drainage. Sorry, I cannot see. The drainage ecosystem, providing, and also the third one, providing the alternative water supply during times of water restriction due to shortage of rainfall event or polluted surface water flood. Okay, so besides using the rainwater as our water supply, so other than that, we can reduce flood. We can mitigate flood from happen, especially in the burn area, like flash flood and everything. So we are getting two advantages actually at the same time. So, and then this literature study aims to integrate issues and challenges related to rainwater harvesting, and we come up with two objectives: to provide insights of possible solutions in overcoming the issues, and to make rainwater harvesting efficient, especially in tropic conditions. Okay, here I would like to highlight the factors that affecting the implementation and efficiency of rainwater harvesting system. There are so many references here, which has debates on various of issues in terms of the quantity, the quality, the technical aspects, and as well as the non-technical aspects. So I've choose some of them. There are climate change and atmospheric condition, microbiological contamination, chemical contamination, energy consumption, design aspects, installation and maintenance costs, awareness and understanding. Okay, so basically, in implementing rainwater harvesting, we need to have these three key elements. What are three key elements? First, collection surface, which is the roof surface, the guttering system, and also a storage tank. So with these three key elements, we can implement very simple rainwater harvesting system at our house. Okay, harvested rainwater for drinking is the potential public health risk associated with microbial pathogens. This has been debated widely. And those contamination may take place in the air, that is called atmospheric condition. During the collection at the roof surface, or even in the storage, or they can come with bioslime, and either airborne dissolved chemical or biological pathogens. Also, so I'd like to discuss about the quality of the rainwater itself. If we compare to the surface water, the quality of surface water, the rainwater should be better than the quality compared to the surface water, which we all know that it may still contain wastewater treatment plant effluent, like in forms of pharmaceutical residues and also microbial contamination. So we cannot deny this, and the magnitude of health risk from non-potable users could be lower than potable due to lower exposure levels of pathogen. So instead of using it for potable purposes, then we use it for non-potable. Okay, a general community perception that rainwater is safe to drink without having to undergo prior treatment. In support of this perception, research by Dilaha and Jordan reported that quality of harvested rainwater is generally acceptable for drinking and has household use. This also supported by Harvard by an epidemiological survey that they found that among 4 to 6 years old children in rural South Australia who drank treated rainwater, that suggested harvested rainwater poses no increased risk of gastroenteritis compared to the main supply of water. Also, common problems with the roof harvested rainwater are related to roofing issues such as debris, trees, overhang roofs, and also bird droppings, which can seal up contaminants or the oxygenate water stores and might also discolor the water, which eventually can lead to diseases. This also includes the roofing material. Okay, we cannot exclude the factors of roofing material, as we know that different material might lead to different diseases, like asbestos or any other roofing material. So we need to check this on the design aspect. So rain events, animal droppings and other organic debris deposited on the roof and gutter that can be transported into the tank via roof runoff. In terms of energy consumption and design aspect also, enhancement of energy performance of rainwater harvesting system will allow an increase of positive trade-off between water and energy services at a building scale, which may improve the performance of the water and energy sectors in the future, as the energy efficient alternative water resources are crucial for the development of water and energy resilient cities. So we might come out with a system that really very minimum use of energy. So performance of pumping and UV system in rainwater harvesting, there are 4 parameters to be considered. First one, energy efficiency, the pump and UV conversion efficiency. The second one, number of startup. Third one, the standby energy usage. And last one, rainwater consumption pattern. So the type of town water backup system is also important. Indirect pump distribution system, automatic switches are more energy efficient. On the other hand, in indirect supply system, trickle top up and can supply town water to feed the tanks without energy implications. So we cannot have the shortage of the energy as well in order to make sure a good supply. Otherwise, we need to provide a good design without without really use or consume energy, high energy. So we have heard this morning about so many treatment for the harvested rainwater, which includes chemical and also non-chemical treatment. But I would like to highlight here as for the result and discussion as for the solution as well. So I opt to choose a non-chemical treatment where we can start with the first flush, the first 20 minutes flushing to reduce all the droppings, all the debris from the roof surface. We can also use UV disinfection instead of chlorination. You can get the UV from the solar. It's what presented this morning as well by one of our keynote speaker. We can opt to use filtration method. They come with nanofiltration, um, microfiltration and everything, but the most importantly, we can reduce all the particles and as well as the microbiological. We can also go for reverse osmosis just in case we do have what we call heavy metals residues from the roof materials to be safe, but this is again an option. So other than that, we can go for activated carbon filtration. It's very low cost, and also we can opt to use slow sand filtration, as I also discussed this morning. And another thing, we can boil the water just in case we need it for potable use. Other than that, we can also increase the treatment by integrating all the suggested system, non-chemical treatment, so that we can produce better water, better quality of water uh, by just using non-chemical treatment, not including the chemical treatment. So because of what, by using the chemical itself, it can produce or it can cause to uh, byproducts. Okay, it can produce byproducts, which means it's very harmful and very uh, not suitable to for drinking purposes, because we know that our rainwater, the quality of our rainwater is not as bad as the quality of surface water. Then I don't think we need to go for the chemical treatment, very high use of chlorine and everything, so that we can reduce the chemical usage and we can do it safely. For the design aspects, uh, we need to embed or we need to provide understandings to all the developers in our countries to have, or our engineers as well, to have a good effective design system for our rainwater harvesting. Uh, by having a low electrical and energy consumption, and so that we can reduce the installation and maintenance cost in terms of the system from roof into the tank, storage tank, and also uh, the maintenance. Okay, how do we maintain, especially the storage part. Okay, we also can opt to use gravity flow instead of using pump, because we know that gravity flow is much cheaper than it's not really cost into uh, high cost maintenance, and the right choice of roofing material. So we need to know that the contractor and the designers need to know what are the roofing material is best to choose to use for the rainwater harvesting system. And we also can integrate with hot water system in terms of microbiological aspect. So when we integrate with the hot water system, we know that hot water system will increase the temperature of the water. Other than that, so in other words, the system itself can reduce the biological agent or contamination of microbiological in that water. So it's not up to 100 degrees C, but at least to 40 or 50 degrees Celsius. But it's still safe to be contact to the skin, and to be more economic with all the integrated, the correct design of the rainwater harvesting, we can produce very more economic, then easy to maintain, because we know that it's not easy to apply this rainwater harvesting without proper knowledge and understanding about the system and also how to maintain it. Okay. So in the perspective of government and policymaker, this is quite important too. the policymakers and the government should come up with insightful policy in order to support this so-called idea of harvesting rainwater and a systematic pool support there. So we're so lucky that this morning we heard that our minister had announced Project Pembinaan Takungan Air Pinggiran Sungai (PAPS), and it already started in Malacca. And this also called a systematic pool support in order that other than we implement or we practice individually, we also can make it a pool support so that just one system and then we support so-called a selected area for this rainwater usage. Okay, so we need to go for minimum installation cost, and also this is it should be included into the policy as well, to make sure that everyone is not burdened with the high cost of the system. And the government also can opt for subsidies, like to start up of the rainwater harvesting system, like giving initial cost, covering initial installation costs, like for example, or cut up for about 10 to 20% or 5% of the cost in this installation cost to all the users. And other than that, the government and policymakers also can give education, can educate people so that the awareness of using rainwater harvesting system will be increased among society and also industries. So the outcomes of this literature study highlighted 4 points. The first one, an important significance for local governments and urban planners in designing and planning future cities. And second one, therefore, the new accessibility, sustainable development of stormwater roof runoff could be promoted in terms of resource availability and quality and fostering rainwater harvesting system. So in this intensive climate change era with an insightful policy, rainwater harvesting can be encouraged as part of the strategies in achieving accessibility of conservation of water resources. And last one, major concern on the implementation of the rainwater harvesting in future is to provide economically portable use of harvested rainwater with minimum treatment. So these are my key references. Amal, Amos Hoffman, Dani, Kempisano, Dibasani. Okay, with that, I thank you very much. I end my presentation today, and thank you for your attention.
Okay, thank you so much, Dr. Azra. Do we have any questions from the seminar members?
Yes. Assalamualaikum.
Yes.
Can you hear
I
me?
can hear you. Very clear.
Okay, all right. Okay, Assalamualaikum dan selamat petang everyone. My name is Hazri. Thank you, Dr. Azra, for your very exciting, very interesting sharings on the rainwater harvesting system. I think being in the industry before, I've seen much of the local councils has implemented or rather enforce the rainwater harvesting system in their policies. So even whether it's small, big, even the high-rise 40-story buildings, a single-story bungalows, you have to provide the rainwater harvesting system, a tank for you to harvest the water. But then my question is that most of the times this harvesting tanks is meant for use irrigations, even for the 40-story buildings that are which I had experience doing managing that buildings, is meant for just irrigations and washings, a common place, a common area washing. That's all. So what's next for this system, and how can this, some other countries in the developed countries, they have changed that into you can really drink that water that you harvest. So whereas us still at a level where said it's just for irrigation purposes as well as for the common washings, whether it's car, whether it's your common floors, or even other things. So we are still behind on that. So it just, talking about policies just now, it's been there, but in terms of definitions or moving forward is, I think that's need to be looked into. Perhaps your views on that. Thank you.
Thank you, AR Architect Hazri, for that question, that brilliant question. So I realized that, in fact, actually, when we turn back 10 years back, this matter is not really popular in Malaysia. But as we go through later, years by years, we can see a lot of houses is readily installed by the developers, just for rainwater harvesting system. If you realize that our new residential area, they already include the system at the very brand new house. So it's not really hard for them to start up the system. And also, in the future, yes, I would like to encourage, we can go through, other than non-potable usage of the rainwater, we can try to go accept this challenge, and we try to go into potable usage of potable usage of rainwater, like Narim has done before, presented by Yayasan Amal this morning. Narim have contributed to the treated drinking water using rainwater. So by that, this is a good start for us. And we also have the taps, and we also have the solar system, huge solar system, solar plant in Malacca. So therefore, when we are slowly into that particular of good implementation of rainwater harvesting system, my guess, I believe on that. So we can see that we are moving, and we are actually catching up with all the technologies of using rainwater harvesting as our part of water supply. So yeah, we just need to keep going without with the acknowledgement of all the suggestions that I included in the slide just now, in the presentation just now. So we can go for a better future of rainwater harvesting system, hopefully in the near future. So I would like, because by looking at the research trend, they already come up with the guidelines and everything for the rainwater treatment, and also in also treating the rainwater from, especially the contamination of biological. So the most important thing for potable usage is to combat the microbiological contamination, so that we can use the water from the harvested rainwater for drinking purposes. So that is my biggest concern about our system nowadays. So if can combat the microbiological, then we can go for drinking purposes. Am I answering your question, AR Hazin?
Okay, thank you very much, Dr. Azra. Can I ask another question?
Yeah, sure, please.
Okay, all right. Hope you don't mind.
Yeah.
I hope the moderator don't mind me asking another questions.
Can I have my question first? Can I have one question first? Azri, can I have
follow the queue. Okay, my second question is that, I would like to refer some of the event that happens last year in Pasir Gudang, whereby a lot of river contaminations that happened in Pasir Gudang. So most of the areas in Pasir Gudang are industrial area, situated in the industrial area. But then and it is now heavily developed, that area. So, and a lot of high rise coming up into that area, a lot of houses that are being built surrounding those areas. So do you think that if you were to implement the harvesting system, right, open air in that industrial area would affect the water that you collect? Your thought on that? Thank you.
Okay. This issue is under atmospheric condition. So Pasir Gudang as we all know, there is the big industrial development in Pasir Gudang. So my biggest concern, it is really a special case. I mean, we need to think of the atmospheric condition before we do the rainwater harvesting system. I'm afraid of what we need to be prepared with all the possibilities, just in case that there are so many contamination, airborne chemicals in the air, and that will contribute to acid rain, for example, and not only acid rain, secondary pollutants, secondary air pollutants that can contribute so many what we call heavy metals in the air, so many harmful molecules, so that we need to have a proper rainwater harvesting system with all the precautions, as the rainwater has to go through the layers of atmosphere that contain a lot of secondary air pollutants and also primary air pollutants before it go through into our harvesting system, our tank, our storage. We need to cater it with our good filtration system, hopefully by using nano filtration maybe, so that we can reverse osmosis, which I think that we contribute a lot more on our installation costs and also maintenance costs, because we need to include so-called membrane filtration method and everything to reduce or to minimize or to make it blank, without to consume the rainwater, harvested rainwater without any contamination, without any disturbance of the harmful chemical. So my suggestion is we need to have the proper rainwater harvesting system for that particular Pasir Gudang case. Okay, yeah, Azri.
Okay,
Thank you, Dr. Azra.
Okay, I have a question for you, Dr. Azra. Okay, maybe
Mr.
it's a good presentation.
Yep.
I just want to compare, okay?
Mm-hmm.
You mentioned, which is true, treated water is very expensive.
Yeah.
For each of us, we drink average 2 liters of water a day. All have to agree around there.
Yeah, yeah.
But you will flush toilet and you flush about 3 times, which is 6 liters, about 18 to 20 liters a day.
Mm-hmm.
After spending so much money treating all the water and you flush the toilet, your suggestion of portable, non-portable is very good. Portable water, we don't drink a lot.
Yeah.
But when you use for toilet, we use a lot. Yeah. So I believe that the emphasis is to move towards non-portable use. Okay, if you can use almost portable use, you'll be okay. Wash floor, wash anything.
Yeah.
As to the design, you already mentioned gravity feed. Please use gravity feed. It's the cheapest, easiest, and so on.
Yeah.
As to the education, I hope one school can be installed with a proper gravity feed system. That's where the education starts. When the children grows up, when they go to the toilet, they flush, they use rainwater, then they'll tell the parents. And then they say, then they grow up from there. But nowadays in school, they just use water like crazy. Most schools don't have water and smelly and so on. And for drinking water, if ever been to Kuala Sangga, which is off Kuala Sepentang in Taiping, it's an island. They got no water, no treated water. They really drink rainwater.
Okay.
I went there, had a drink of their drink water, but they had to boil. So if situation allows, you have to drink. But remote area, I believe, if the roof is correct, it's safe to drink.
Yeah.
Right? I believe
especially,
so. But you need to drink.
Especially in the island area, they have a clean air. I mean, clean air.
Clean air. Yeah, very good. Thank you. Thank you for your sharing video.
Yeah, thank you, Mr. Gary, for your insight too.
Perhaps one last question from me. What question? Just
Prof.
sharing. Okay, just to share with participants listening to this seminar, the Universiti Tun Hussien on Malaysia actually install a rainwater harvesting system. Okay, what happened is that the design was that rainwater will be collected and will be used to flush toilets, especially in our dormitory areas. Okay, the thing is that the water were collected in the ground system, and the campus soil, unfortunately, are acidic. So when the rainwater mix with the groundwater, with the since the wells were in the ground, it became very acidic, and therefore that resulted in all the flushing systems become corroded. So this is what I'm sharing with the participants here, that when we design system, rainwater harvesting system, we have to be careful. We have to take into account many aspects, not only the quality of the rainwater itself, but if the design itself. Okay, thank you. That's just I just want to share my experience in this area.
I want to comment on your comment, Encik Ahmad Tabizi. Number one, when it reach rainwater is collected from the roof. Once it hit anywhere on the ground, it's no more rainwater. It's called grey water. That's number one. There's no study. Look at the definition. Number one, I'm an engineer. I can tell you this. Number two, nobody use except plastic pipe. Nothing to do with. If you use some metal pipe, this guy is not. He's from somewhere else. Nobody use metal pipe.
It can cause corrosion.
Always use plastic pipe. They will never corrode.
Yeah. I
I
agree with you, Engineer Gary.
it shows the guy who designed the thing don't know what he's doing.
That's right. That's right. I don't want to mention that part.
Yeah. I can tell you, I can say hundreds and one. Number two, very important. Anything on the ground, it can never be drained off. Sediments will come in. Whatever filtration system.
That is what happened actually here.
Exactly what happened. The country lose so much money.
Yeah.
It's very sad,
Right.
But when I ask people to do gravity feed, nobody likes it. No money to make. There's no money to make. Because underground tank is very expensive. A lot of money. Everybody is happy.
Yeah. Yes.
I can tell you, I'm going round.
Very interesting discussion.
It's a joke.
Unfortunately, we have run out of time.
Okay. Thank you.
Sorry.
Thank you, Prof. and Mr. Gary.
Al Hazri, Mr. Gary, Prof. Tamizi, and Dr. Azra for the exciting and useful discussion and presentation. I think we can see now how rainwater harvesting system is very interesting to be deployed and explored, and hope it will provide methods to support the governments and public communities in benefiting the rainwater in whole. Okay, ladies and gentlemen, members of the Zoom, before we end, on behalf of the committee members, I would like to express my utmost gratitude to all distinguished presenters and members of the Zoom for making the presentation session running smoothly. Thank you very much. Okay, we will resume our seminar again tomorrow at 9 a.m. with the keynote speech and closing ceremony. Till we meet again tomorrow, inshallah.
Take photo.
Be safe.
Okay.
Thank
you, moderator.
From TATI.
Dr. Susana, take photo.
Okay, now
don't forget.
Let us have a photo session first before we signing off. Okay, you can, all audience can switch on your camera. Let us have a photo session. Okay. Okay, 1, 2, 3. Second, freestyle. 1, 2, 3. Okay.
Okay, thanks, Prof. Tamizi, joining the event.
Bye.
Okay, thank you very much, everyone, for